Hi. Okay guys, so in this video I'm going to show you how to calculate the position with constant acceleration. Okay, so it's the position when we have an accelerated motion. Okay, so I'm going to show you this problem right here. This says number 2. Race car travels on a straight racetrack with a forward velocity of 44 meters per second and it slows at a constant rate to a velocity of 22 meters per second over 11 seconds. So the question here is, how far does it move during this time? Okay, so there are two different types of formula to calculate this one. I'm going to show you using the one that we use during the class. Okay, so this is the formula for determining the position where we have an accelerated motion. Okay, so this is the formula. Okay, so the final position will be equal to the initial position plus the initial speed times the time interval plus a half of the acceleration times the time interval squared. Okay, so this is a large formula is to obtain this position, but in this case, as you can see here, the question is not calculating the position. The question here is, how far does it move during this time? So how far is a question that asks us, like, what is the distance traveled, or was the displacement of the object. In this case, we have to assume that they are asking about the position of the object, like the final position of the object. Okay, the object in this case a race car. All right, so I'm going to use this formula. The thing here is that I don't have one of the data that I need to have it right here. That is the acceleration. I don't have the acceleration. This one, I don't have it, but I can calculate it. So I have enough data to calculate the acceleration. Remember that it says that the car is slowing to a velocity of 22 meters per second. So 22 meters per second is the final speed. And if you remember from the other problem, the acceleration is equal to the final speed, minus the initial speed divided by the time interval. Okay, so if the final velocity in this case is 22 meters per second and the initial was 44 meters per second and the time interval is 11 seconds, that means that the acceleration will be equal to a negative 2 meters per square second. Okay, so I already have my acceleration. It's gonna be negative because it's slowing down, and now I can actually calculate using the large formula. The only thing here that you need to check right here is that we don't have an initial position. They don't talk about an initial position, so we can assume that the initial position is 0. Okay, so I can continue with the rest of the formula. Okay, so x will be equal to this, that is the initial velocity times the time interval, and the initial velocity was 44 meters per second. So I can have like that, 44 meters per second multiplied by the time interval, that is 11 seconds, plus a half of, okay, now it's a half of the acceleration, that is in this case negative 2 meters per square second, times the time interval, and in this case is 11 seconds, squared. Okay. Okay, so the answer for this is 363. So it's 363 meters. Okay, so it's 363 meters, and it doesn't say anything about a position, a direction. So it's only 363 meters. Okay, and this is 363 meters. This is how far it went. Okay, that's how much it moved during that change in speed. Okay, guys, so that's all for this video. I have it. You can watch the next video. It's about free fall. Okay, so see you guys in the next video.